That was easy.
Okay, it just told me it's recording.
Good. That's what it should be doing. Yeah, must be recording. It says it's recording. Okay.
Okay, so I'm seeing Christopher's uh, avatar or something. It's a blank screen. I'm also seeing your phone, which is showing me the rocket. Another blank panel for Aiden, Steve, and then somebody in the lower right corner who is just labeled as iPhone.
Probably me, Mark Langhenry.
Yes, that's you, all right. Okay, well, thank you all for meeting now. One of the teams had issues trying to meet in the afternoon, so I'll be meeting them in the evening next week. I guess the Ezra actually sent us a checklist this time, which is nice. It's the first checklist I've gotten from them for anything. What I think I want to do is handle this more or less the way I've done it for in-person reviews. Just start at the nose cone and work back, and I'll try to hit the points on the checklist and the things that I already had questions about as we go. So let's start by zooming in on the nose cone here.
Okay.
And I don't know why I'm using my, you guys can't see that I'm using my mouse to indicate where I'm pointing things. And of course you can't see that at all. I like your tip protector there. That's nice.
Thank you.
Okay, so yeah, nose cone looks like carbon fiber.
It's fiberglass.
Pardon?
It is fiberglass.
It is fiberglass. Okay, I saw the color and made a guess.
Yeah.
What does your shoulder look like on that? Okay, I'm having a little bit of trouble with your audio. I'm having a hard time hearing what you're saying. I'm giving you I'm looking at how to set the view here, so I'm getting more view of just the rocket.
I don't think there are any settings.
What?
We disconnected.
You unplugged? Oh no. Okay, hold on. Man, what? Why did it? Sorry. Anyway,
is the mic coming out of the laptop?
Do we still have microphone? It looks like we do.
It actually just got much better than it was.
What?
Yeah. So we need to move the laptop closer to you because you're across the room.
Okay.
That's what we were trying to do.
Well, you can't. Okay. Well, we're going to mute this laptop and switch to a different laptop. Yeah. Okay. Is your laptop now unmuted?
Yep.
Okay. So we have sound again?
Yeah, how does that sound?
This is sounding much better again.
What it? No. We should be getting sound out of this laptop. Oh my goodness. Oh, we're gonna get feedback. Unmute yourself.
All right, how does this sound?
Nope.
That sounds good.
Okay, just give us one moment. We're just gonna make sure everything's good, and then we'll keep going here.
Okay.
Good.
Turn off the sound. Yeah, it is off.
We're just trying to eliminate feedback here because we have a couple devices that are in the lab that are all connected.
No, this is just Oh, staff and interest meetings. Let's figure this. No, I can't leave. Oh. I don't know how this last you the thing. I'm gonna figure out when it's yeah, third.
Use that one.
Is what? I don't know how there's
For future reference, you always want to rehearse these things.
Very true. Very true. Yeah, we had a few minutes to prepare here, but obviously technical difficulties have got the best of us. Okay, I think we're good now. Yeah.
okay.
All right.
Awesome. Back to rocket science.
Okay.
Okay.
All right. Where were we? No,
Okay,
no,
we were
no.
just going to look at the shoulder.
Yes.
Okay, the shoulder that looks like about at least half a caliber.
I think so, yeah.
Okay, how is it bonded to the nose cone?
Well, it currently isn't, but we're going to epoxy it in place before we fly.
Okay. Let's see, what are you using as a eye bolt or something here?
In the top of the nose cone, we have the stock cords. It's a little blocked off right now. There's Chris, turn around and speak to me. Oh, I forgot the microphone over there. Yeah. There is an eye bolt in there.
Okay, and I can't see it. Is that forged, welded?
It is forged. There's
Okay.
another one on the table, but if you want to grab that. Can you turn around, Chris? I can't move. If you turn that phone flashlight on, that could help.
Yeah, I can put it on this one. I can't put it on.
No, it's not that one. Oh my. It is. Oh, whatever. You definitely can turn the phone flashlight. Oh, you can't turn the phone flashlight off. Interesting. Okay. It is Ford. It's
Okay.
it's on it's Ford 20 and the rest of the ball is about. But I don't know where our other one. So there's another same one on the forward centering ring that might be a little easier to see once we get
Okay.
down there.
Well, I'll try to remember that when we get to it. That's a Kevlar shot cord.
Yes. Half inch,
Uh,
I think.
Okay, what are you using for knots?
Well, we have a knot marking the position of where the main parachute attaches, but it's just a little
We're also using quick links to
overhand knot, it looks like, yeah.
At the end here, where it's connecting to the nose cone, what knot are you using there?
The shock cord has a loop in it, and we pass the rest of the shock cord through the loop on itself.
Okay, so that it was supplied with a loop.
Yeah.
Okay, so it's a splice.
Mm-hmm.
Okay. And all you've got in the nose cone is just the parachute.
We'll also go up there, but the payload adapter isn't finished yet. We have some questions about that at some point, about what's actually allowed because we're a little confused on the rules. But there will be the payload going as far up into the nose cone as it can go to fit in the, square size.
Okay. How does the shot cord get around the payload?
Well, depending on how it's going to be attached, we have. Hmm?
Do you want to show them?
No, it's fine.
Yeah.
We've two leading theories. We can make a sort of traditional payload mount, and then in the round spaces around the square payload, I can only just kind of wave my hands on this.
Do you have the payload there?
No. The payload will be a boilerplate mass, and we haven't made it yet.
Okay. And I'll point out you're running a little late on getting this stuff fabricated.
Oh yeah.
Something you could do, especially with a boilerplate payload, is go ahead and put all thread coming out the top end of it, and screw that into your nose cone tip instead of the eye bolt you've got. And then
That's one.
put an
That's
eye
what we
bolt at
were.
the bottom of your payload.
Yeah, we were thinking that would be the easiest option. We just couldn't find out if that was actually allowed or not. But it
Um,
sounds like it is allowed, so that's pretty good.
well, okay. Before I get you in trouble,
Okay.
where in the DTAG are you seeing things that have you concerned?
Um, well, so I remember reading a discussion on the Hero X about putting attachment hardware into the payload volume and how it was okay. And then we talked to Steve and we were thinking like having the payload be a structural component was probably not what the rules were intending. So now we're a little confused on if we were going to get away with that or not.
Okay. And when you say Steve, you mean Steve Lobliner.
Yes.
Okay. There are many
Joe,
Steves.
just to explain the logic on that, a payload is not supposed to be part of the required airframe. That was the
What
logic.
and
Okay.
one idea we had to work with that was the payload could be have a hole running through it so that you could take the payload out and leave the threaded rod in place for structural reasons. But then we were wondering if having a hole in the payload is what was intended or not.
Yeah. Let's see. I'm looking here for what the DTAG says about the payload. Okay.
Joe, you may also need to look at the payload rules on this stuff.
Yeah. Recovery systems. Okay, there's nothing about that I'm seeing in the DTAG. And let me go find the payload rules. Okay, Steve, did you mean the payload challenge rules?
Yes.
Okay, I have not actually even looked at those. I thought that was only for active payloads and people participating in that challenge.
That's what we were under the impression of as well.
Okay, so now I need to.
And I don't see how, from a safety standpoint, which is my brief, how having the payload as a structural component is a problem. I can see I can see it's not in the spirit, but
That's the question here is, I mean, theoretically, a payload is not essential to the operation of the rocket. So again, you're right. It could be spirit versus letter of the law.
and I think every rocket we're sending up is depending on the payload for its stability.
Yeah, I would agree with you.
And most of them would be unstable if they were flown without that 9 pounds of lead in the top.
Yep. you're judging the team here. Again, I'm just the fire of record here. Your judgment rules.
And from a safety standpoint, it's fine. It's fine as a as a safety issue, and you're not going for the payload challenge anyway.
Yeah.
So I'm
Okay.
going to say it looks good to me.
Okay, well, we'll move forward with that then. That makes things pretty easy.
See, where were we? I think we just pretty much finished up the nose cone,
Mm-hmm.
and then we have the forward section of the airframe, which is just fiberglass.
Yeah,
Out of curiosity, did you get that from Wildman?
we did.
How maybe after we're done and after we're not recording, I've got a question about that.
Okay.
Let's take a look at the front end of the avionics bay here, the eBay.
Here, Chris.
Okay, so that's a
you the
fiber.
avionics thing? Sure. We have Chris, the other Chris, to talk about avionics now.
Hi.
Hello.
So this is the forward end of the avionics bay. So to connect, this is to the shock cord, right?
Yeah.
We have a U-bolt that will connect to the shock cord right here. And would you like us to disassemble the avionics bay to pull out the electronics?
I will in a moment, but something I'm curious about first is, okay, I see your two charge wells there.
Yes.
Are you using black powder?
Yes, we are.
Okay, how are you getting the igniter to the charge well?
Currently, for testing, the igniter has just been run through this hole. We've only tested one charge well at a time.
Okay.
And in the future, we're going to add another hole on the other side for the backup charge. And I think two more holes so that we can screw the charge well on and run the igniter through a different hole.
Why run it through why do you need more than one hole? I mean,
Well,
for igniter.
one hole would be occupied by a screw that holds the charge well in place.
Okay, this looks like the charge well is screwed to the bulk plate there.
This plate?
Yeah, the fiberglass plate, whatever it's called.
Yeah.
Okay, that's the word.
Okay, actually, I think I may be seeing this wrong. You've got your U-bolt here. I go straight up from the U-bolt, and what am I looking at?
Oh,
Yeah,
these are threaded rods that go
Oh,
actually
okay. From the
Yep.
angle I first saw them, that they look like they were hollow, and I thought I was looking at
Oh,
the.
sorry about
Yeah.
that.
Okay, everything is making more sense now.
Yes.
Okay. So are you looking at having your charge containers just flopping around loose in here, or taped down, or screwed down, or?
Screwed down. We're gonna add
Okay.
more holes to screw them down onto the bulkhead.
Okay. Will you have? Are you running the igniter wire up through the bulk plate, or are you putting electrical connectors up here?
Through the bulk plate.
Okay. And I ask because something that had never occurred to me as a problem until Ken Overton pointed it out last year is if you've got a quick link up here flopping around, and you've got electrical connections down here, you can have a short circuit, and that can cause a failure. That had never occurred to me until, and I had been doing it that way for years, and so far as I know, I had never had a failure from it, but it would have been a possibility. Okay, let's go ahead and open it up and take a look inside. And while you're doing that, I'm going to go find your wiring diagram.
Okay.
Thank you, friend. Just gotta like keep down. There might be one that later. Don't worry. There's a virtue dedicated class actually. Upside down. Well. All right. Sorry about that delay. So this is our avionics tray. So we're running three pieces of equipment. This is our telemetrum. This is our main dual deploy system. This is our backup deploy system. This is the Blue Raven. What's that? Featherweight? Featherweight Blue Raven. And then we also have a secondary GPS, the Featherweight tracker.
Okay. Yeah,
And they're all running off of screw switches for to turn them on.
okay, and they all look, yeah, all look completely independent.
Yes.
Yep.
They're all like independent battery systems.
And I'm going to ask you the same question I'm going to ask the other teams I'm looking at. Your wiring diagram. Why didn't you just write a normal schematic diagram? Why these funky pictures?
I think that was originally
Were made very early on before we had the components and knew exactly what our plan was. They're actually outdated currently. We have
Really?
different wiring systems now. So
yeah, we'll have an updated diagram.
in our final,
Yeah,
Okay.
it'll be much simpler.
More professional looking.
Yeah. Okay, that all looks reasonable. How are you getting access to Armit?
so from our outer shell on this shoulder.
Okay.
Is this slot that we've drilled, and from there we'll access the screw switches with a screwdriver. So it'll line up something like that.
Okay. Do you have vents other than the screw holes there?
Yes,
Yeah.
we'll have to double check to make sure that they're the right diameter so that we have enough airflow.
And you've actually got, I have no doubt, plenty of airflow just from the screw set
Yeah.
switch.
Right.
It's a very low. So I think
Very big hole.
we have one on the other side, and then
Yeah.
these are shear pin holes.
They don't benefit that shit.
It's another vent hole on the other side.
And I worry about having too much airflow, but having two more on the sides would not be a bad idea. The way you've got it set up now, it's more susceptible to wind gusts, giving faulty readings than if you had had them going all the way around.
Okay. So you're saying adding two more here and on the backside would help or not
Yes.
help? It would
Yes,
help.
would help.
Okay.
And this gets into stuff that we've done it this way for forever, and I'm not sure, given how good the electronics is now, if it's really still necessary. But it certainly won't hurt.
Okay.
Yeah, that makes sense.
Okay. Now, did you say the holes up above here in the coupler are for shear pins?
Yeah.
Why are you putting the shear pins on your avionics bay instead of up at the other end at the nose cone?
Only separation points are on either side of the avionics bay.
Why?
Um,
There's a norm, the what I'm used to seeing here is the separation points are at the nose cone and at the fin section. And that way, when your deployment charge fires, it tries to push the laundry out instead of sort of instead of pushing the laundry up into the body tube and relying on inertia or something to finally pull it out later.
Interesting. Okay. Um, huh.
So you normally
I
see
never,
solid attachment points on the avionics bay and shear pins at the other end of the tubes.
I guess just to interject here, the payload, and I think they're still looking how far the payload sticks back into that tube.
yeah. I mean, because our two parachute bays, we have the motor mount going up to here somewhere. And then we've got the drone parachute here. And then same thing on the other side. We've got the
Okay.
main parachute and then the payload up from there.
Okay.
Interesting. I mean, not that I've been around very much, but I haven't seen that before. I've always seen avionics bay kind of made up of couplers like that.
Well, yeah, the avionics bay is always made up of couplers like that. It's what's connected to it as a hard point and what has shear pins. And
Hmm.
and we hadn't gotten to the fin section yet. But yeah, if the fin section is attached straight to the avionics bay, then yeah, you need shear pins there.
Yes. Right. Yeah, we've got like the matching holes on the fin section there.
Yeah.
And same thing on the forward section as well. I mean, they're very small. You can barely see them, but
Yeah.
they're on the other side. Yep. Anyway,
Okay. Let's see. Let's head on down into the fin section
okay.
and
You barely see that. Gonna point down into the top. We see there.
okay. And so you've
There's
got
a
a
You want a flashlight? I think it's.
So there is the eye bolt that the shot cord is connected to, which I guess you can barely see. It's looped around the same way as it is in the nose cone.
mhm.
And then the centering ring, the end of the motor mount, and the forward closure because the motor case is involved.
Right. You've got the eye bolt just going into the centering ring there, and
Yeah.
a nut and a washer on the other side.
Mm-hmm.
How did you secure the nut so it can't come loose?
It's very well tightened, and I think it's even got a little bit of epoxy in it.
Okay. Yeah, that's something. If it comes loose, you'll never fix it. So you want to make sure
Right.
it can't come loose. But yeah, epoxying it is epoxy, red Loctite, anything like that is a good way to do that.
Mm-hmm.
Now let's see. We talked about this a little bit before. Why JB Weld for your fins?
Well, the club has used JB Weld a lot in the past. Seems very strong. Um, I don't think these are going to come off, but you
Well,
never know.
and you're right. I'm going to say it is not a bad choice in the sense that yeah, I don't expect your fins to come off, but it's far from the best choice for this application.
Yeah, we have a lot of experience working with JB Weld. We use it for all of our smaller rockets, so everyone's used to working with it and how to best use it.
Yeah, and it's
And we already had a lot of JB Weld.
the best possible reason to choose something.
Yeah.
Yeah. You might want to look into some of the lighter weight epoxies for lighter weight and stronger epoxies for sort of future reference.
Okay. Yeah, we'll do some research for next year.
What are you using for motor retention down here?
Well, We've got an aero pack.
Good choice.
Big screw things,
Yeah.
motor case.
Um, I'm and again and this is a choice that certainly is just almost personal preference. But why did you choose the flange style instead of the epoxy onto the motor mount tube style?
I didn't know they sold the. I mean, because our subscale rocket has the epoxy onto the motor mount style.
Hmm.
I didn't know they had that. I only ever remember seeing the flange style, and I thought it'll fit. So, and it seemed like it would be okay.
Yeah. Well, and it certainly will. I'm trying to remember what your motor size was. Is that a is that
It's a
a
Aerotech 4 grain case. Um, it's
is
a
that looks
M2000.
like a 98 millimeter?
Yes.
Okay. So the 75 I know has the other style of aero pack. I would have to check to make sure that what I'm telling you to use really exists, or telling you I would have used really exists. Okay, that all looks good. That looks like a rock that will fly. Now I'm looking at the checklist to see if I missed anything. There's some rocket markings that are supposed to be on here. Your team number and the frequency if you're using ham radio, but there's a pretty good reason why that isn't there yet.
Yeah, painting the rocket is hopefully starting this weekend. We wanted to wait until all the tests were done, and so we wouldn't scratch up the paint.
Well,
But
has your motor actually arrived?
yeah,
Good.
it's all in the closet. We haven't opened it yet because of,
Okay. And the reason I'm looking over to the side is I'm looking over at this checklist to make sure I've caught everything.
I would just make a suggestion, Chris. Look at the motor, do an inventory, make sure all the parts are there. Because on the field is not the place you want to find out that, oops, something was wrong with the motor.
Yeah, we'll do that.
Good point. There was somebody I saw several years ago going for a level 3, who was going to build their motor at the field. Mistake number 1. And when they opened it up, there was no O-rings.
Yeah, well, I've sort of looked through. We do definitely have a lot of O-rings, but I haven't checked if they're the right O-rings yet.
Yeah.
But hopefully they are.
We'll check that
We
this,
will.
this weekend.
We'll check that later.
Where are your rail buttons?
On this side.
Well, where are they going to be? Oh, yeah, okay, that one is there. And yeah, that looks
There
good.
they are.
Pardon?
The forward one is accessible by hand on the inside. The aft one is of course not.
Right. Have you gotten the speed off the rail up a little bit?
No. I don't know how you can get the speed off the rail up without making the rocket lighter, which
Well,
is a tall
difficult.
order. So in substitute, we did a scale model test flight with lower speed off the rail, even proportionally, and it seemed to fly pretty well.
Yeah.
We can pull up the video if you want to see that.
I don't need to.
Okay.
You need to make sure that you are going to be able to justify that. It was 92 feet per second, right?
With the effective rail length, I think it was a little lower.
Okay. Be sure that you have a good set of go no go guidelines, so that you can say, we are confident that we are fast enough if the winds are no faster than some value.
Okay.
And something like, and I don't even know what a good angle is, but your effective angle of attack is okay until the winds are at 15 or something like that. You want to be able to make a point that you've seriously considered this.
Yeah.
Oh, and I'm sorry, something that I meant to bring up a while ago and I forgot, and I'll bring it up now, is your report mentions that your batteries, your LiPo batteries are, I think the way you phrased it was supplied by the supplier. Um,
Not sure about that.
do you mean that they were supplied by the manufacturer of the respective um,
Yes, so
flight
these are the
computers?
batteries that were recommended by, so for the Telemetrum by Altus Metrum and for the Tracker and Blue Raven by Featherweight. In the case of the Featherweight ones, they're purchased directly from their website. And Telemetrum was purchased through a different vendor.
And Ezra would really like to get rid of lipos altogether. I witnessed 2 lipo fires myself last year, and they are sort of budging on using batteries supplied by the manufacturer of the uh, altimeter.
Yeah, those are the ones that we purchased just to be very careful about being within the rules for this year. It's definitely something we would look into not using lipos for future years.
Well, you mentioned that you're using one that Altus Metrum recommended that you bought from someone else.
The Altus Metrum doesn't sell any parts themselves, so these were ones that were listed as Altus Metrum batteries by the same vendor we purchased the Altus Metrum from, which I believe is Lock Precision.
Okay. Um,
And
yeah,
yeah.
that should be okay. And actually, Altus Metrum does sell their own stuff. I'm trying to remember what the website is. It's not altusmetrum.com, but
Interesting.
Dale Garby and his brother have a website,
Okay.
and so that is. But yeah, I think if you got the altimeter and the battery from the same site, that will fly.
Okay, yeah, that is what we did. Yep.
Okay, so I'm looking again here. Your fin flutter calculations. I remember I mentioned to you that the calculations we've all been using for 20 years were wrong. Have you rerun the calculations with the corrected formula? Or did you get it someplace other than Apogee's Picaflight newsletter?
What? The person who did the fin flutter calculations isn't here.
Okay.
And it's been a while since we did that, so I'll have to go check. But we can still rerun them anyway for the report.
Yeah, please do that. Okay. And that's sort of everything I can think of to ask you. And yeah, you are close to have a flyable rocket.
Yeah.
You want to make sure you get that. And so we'll see you there.
Okay.
Sounds good.
Well,
So
thank you.
You're welcome. Yeah, Steve.
Yeah, one thing that I've been asking about, and I know the status of this team, obviously, but I typically ask about their checklists as far as what they have for checklists, as far as scrub procedures, recovery procedures. So just something for you for the future. That's something I usually ask in these reviews.
Okay, I was figuring I'd be, asking that at the cup because I can't really look over the checklist very well here. But I will ask, you guys do have them, right?
Yeah, we've been chipping away at creating all the checklists, and they're pretty they're getting there. I mean, they're almost done, you know.
And yeah, thank you for reminding me this, Steve. One thing I'd caution you on is make sure that they are absurdly detailed. We have had teams who have had checklists like put the rocket on the rail and arm it and insert the igniter. And they have been sent back to their hotel room to write a real checklist before the next morning.
Yeah,
You
our
want a
checklist has
checklist.
been very detailed so far.
Good. You want a reasonably intelligent golden retriever to be able to follow your checklist.
Okay.
He upgraded you from a Irish setter.
Well, golden retrievers are brilliant dogs, but I'm
Yes,
not
Irish.
asking for
That's why I
something as
mentioned
smart
Irish
as a.
setters. Irish setters are the blondes of dog world.
And how you find a smart blonde?
No.
A golden retriever.
Okay.
But I'm not asking for like a border collie level of intelligence here.
No.
Sounds good.
Okay.
Yep.
And let's turn off the recording for a second here.
All right.
One